All right. Yesterday we started looking at the Venn diagrams, and okay, so if I have a Venn diagram in which I have three, okay, we'll make the whole board the universal, so it includes everything on all the sets and everything not in all the sets. Okay, so what happens if I'm like to begin with? I always want to find this guy first, okay? You want to find the n one first, and then we end up subtracting everything else from there. So for example, let's say I had A and B, let's say, okay? A and B had 15 between the two of them. Just random number, okay? But all three had 7. So if A and B have 15, then that means that there would be 8 here. And I calculate all of these n's by subtracting from that middle guy. All right? So it's easy enough to do these questions when they give you all the information. But what happens when they don't give you this guy in the middle here or one of the other n statements? So how do we find out what it is? So they give you an equation. It's not really an equation, it's just a set of steps, basically, is what it is, in order to solve for this. Okay, so I'm going to go through this and then I'll make it make a little bit more sense to it. I'm just going to take a look. The big one is 2, 3, 4, so I'll get to that in a second. Okay, the union of sets A or B, or A or B, sorry. Struggling here. A or B consists of all elements in A or B or both. It is represented by the entire region of these sets in a Venn diagram. Okay, so first things first, this notation right here. That's called the union set. That means it's everything in A and everything in B or both. Okay? So this is union. A and B, so this is or, this is and. A and B is everything that's in A and in B. Okay? So everything in A and in B. This intersection of sets A and B consists of all elements shared by both sets. It is represented by the region of overlap on a Venn diagram. The principle of inclusion and exclusion states that, okay, to calculate this, and I don't like using the word calculate because this isn't really a formula. It's just a set of steps in which you need to solve it. To get A or B, you take all that's in A, you add it to all that's in B, and you subtract all that's shared between them. Okay? Is everybody okay so far? All right. The next one that they do for this guy, and it's not one that I use ever, but I'll show it to you anyway, so don't copy this one down. All that's in A, given that we know it's in B, that's what this line means, given. Plus all that's in B, given we know it's in A, and add A and B. But we're not going to use this. This is part of the exclusion, exclusion. So I just wanted to show you that and show you what that line means. All right. Okay. So let me show you an example of this. Okay. And if there's no A and B, that means that there's two disjoint sets. So all you have is all that's in A and all that's in B, and that's your OR statement. That's your union. Okay, so this is for disjoint sets. I'm doing a great job of explaining this morning, but n of A plus n of B, and I don't subtract anything because there is nothing that is common between the two. Okay, so here's the thing. how many black cards are in a deck or queens? 2. Okay. No, listen to this again. I want the number of black cards in a deck or queens. 28? Okay. So the first thing is, how many black cards are in a deck of cards? Half, right? We all agree? So there's 26. How many queens are in a deck?
4.
2. So then I subtract 2 black queens. So there is. Does everybody understand that? And that's just simply a principle of inclusion. Okay, so A or B. All I do is I add A to B and subtract all that are the same. Is that an example we can understand? Yeah? Okay, so let's look at this farmer's market question here. The following produce is sold at a farmer's market: corn, apples, onions, beets, carrots, parsnips, tomatoes, asparagus, beans, watermelon. Determine the number of food types with each quality. How many of them are round? How many of these are round? 5. Apples, tomatoes, onions, watermelon, beets, we consider? Sure, okay, good enough. How many of them grow underground?
4.
Which ones? Onions, beets, carrots, parsnips. Who knows what a parsnip is?
Something's white or red, not any taste like
Shows you how much I eat.
it. They're like white carrots.
Yeah, they're.
Oh yeah.
They just don't really have a
I
taste.
don't eat them.
Oh yeah.
Okay, so either round or it grows underground. Okay, so now, either round or grows underground. So how many round ones were there? 5. Plus, how many grew underground? 4. How many of them were round and grew underground? 2. So 7 that are either, right? Okay. So is neither round or grows underground, nor or it doesn't grow underground. So this one's worded a little bit different. Okay, so I want neither round nor grows underground.
Beans.
Which one?
Beans.
Beans. Is there any other ones? How many do you think?
3.
Yeah, 6 to get them.
Okay. I'm all right with that. So what would you say they were? Beans, asparagus, corn. Okay, so look on the right side of page 69. On the right side of 69, they drew a Venn diagram for you. So that, to me, is the easiest way to answer any of these questions without using your steps there. Write them out, put them on the Venn diagram, and then it's easy to answer questions like that. Does that make sense? So far? Okay. This one's going to be fairly straightforward because you're only dealing with two sets. Okay, so what happens if we have 3 sets? All right, so go ahead.
Then you have to add a third circle
That's
to the
right.
bottom.
Okay, so let's look at 3.4. That's what we're going to do. These ones are a little bit, they're like puzzles, so they're kind of fun to do. Okay, so first thing you need to make a note of is that that box tells you the order in which you want to solve for these. Okay? So to represent 3 intersecting sets in a Venn diagram using 3 intersecting circles, you want to do it as follows. A and B and C. So that's your middle guy. So you're doing all three ends. Then A and B, then A and C, then B and C. And then after that, you can just subtract to get the rest of them. Okay? So this equation here, you're going to want to put on your equation sheet. So I've got N, A union B union C. So what does that represent?
One that everything overlaps.
Nope. What does that one represent?
A or B or C.
A or B or C, so that means everything that's in A, B, or C in those sets. You understand that? Okay? If it was upside down, okay, and that's how I tell the difference between or and and. This looks like an A to me. Right? So that's how I remember that it's not an A, or that it's union, and union means or. So it's all of them. So to do this now, I do all of A plus all of B plus all of C, right? And now I've got to subtract. So what am I subtracting? A and B, subtract A and C, subtract B and C. And then, at the very end, I actually add. Make sure I add A and B and C. So I'm subtracting these three because I've already got them in this. Okay? So this is to get all of A or all of B or all of C. Question so far? Okay. So we need to keep this up here. Let's look at the example. 25 students. So we're looking at grade 12 math class. 25 students have a tablet, an MP3 player, or a cell phone. 15 students have a tablet, 14 students have an MP3 player, 13 students have a cell phone, 5 students have a tablet and an MP3, 4 students have a tablet and a cell phone, 2 students have an MP3 and a cell phone. How many students have all 3 devices? Okay, so the first thing I'm going to do tablet, MP3, cell phone. Okay, what's the question asking us?
How many have all three?
How many have all 3? That's what I'm asking for right there. Okay, so far? Yeah? All right. So, how many students, starting with this equation then, or these steps, do I know which ones of these do I know? Well, do I know the first one? Do I know A union B union C? Do I know how many have 1, 2, or 3 of them? Yeah, how many? 25. So that's what I start with. So I have 25. Okay? Do I know A? Do I know the individuals? Yeah, how many have the tablet? 15. Plus 14 plus 13, subtract. Okay. So now I gotta subtract. How many students have a tablet and an MP3 player? 5. 4 students have a tablet and a cell phone, right? And 2 students have an MP3 player and a cell phone. So when I'm subtracting here, I also have to add x to each of these three. Because that's included in all of them. So I have, I missed that, I'm sorry. How many have a tablet and MP3 player? So I go x plus 5. Subtract x plus 4. Subtract x plus 2. Right? And then I'm going to add x at the end. Okay? So again, all I'm doing is following what my steps tell me. How do I get A and B? So let's say this is A and B, these two are A and B right here, right? It's everything in here. Right? B and C is everything in here. So I got X and this. I've got X and this. So that's why I get X plus 5, X plus 4, and X plus 2 here for this. We following so far? Okay. Because that's the hard part, setting that up. Now it's just algebra from this point, but that's the difficult part. Okay, so from here, I got what? 15, 29, 42. We'll subtract it to this side. That's going to give me negative 17 over here. Equals. So I got minus x, and minus x is minus 3x. Add an x is minus 2x. Minus 5, minus 4, minus 2 make minus 11. Okay, I'm doing quick math here. So we don't have to be here all day. Right? I'm going to add 11 to this side. What do I get?
6.
Therefore, x is equal to 3. So if x is equal to 3, that tells me that how many students have all 3 devices? 3. How many students have only 1 device? How do I find out how many students have only 1 device? Well, let's go back through this now. So let's set this up. And let's go through. We know what the middle guy is. This is 3. Okay? So how many have a tablet and MP3 player? 5. So that means this is 2. Agreed? Okay? How many have an MP3 player and a cell phone?
2.
2? I gotta do that. This is not right. This has to be 5. Okay? And then what was the other one? Tablet and cell phone? 4. Okay? Hello? There might Jeff probably. Okay, I'll come get him in a second. Okay. So then we go through and add all of those up. 2, 3, 4, and 5. What does that make?
14.
14 have more than 1 device. Right? So how many are left with that only have 1 device then? Out of the 25?
11.
11. There's your solution. Okay? So it's not that hard. Alright? We did 3.1 and 3.2 yesterday. Do we have any issues? Okay, so this is an easier section to get through. So you've got 3.3 and 3.4 to work on today then. Okay? All good?